Yeah, I'm about to fade away. Cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden I don't look at anything the same way. Got a buildup of my thoughts sitting in an ashtray. I'm sorry that I'm so inconvenient, okay. Just let me be me and I'll stay out of your way. I can see the way you look at me, I'm such a disgrace. I never really asked to be brought into this place. You wanna love me? Well then baby I have a taste. All the highs and the lows, no you'll never be the same. I don't really wanna hurt you but I can't control the pain. If you're sticking by my side, maybe we could be okay. Okay, maybe you could be the change I need today.
Already mic testing. Okay, perfect. Let me go to my main camera. There we go. Already we're live, and as you guys can tell by title and thumbnail, today I'm going to be working with clustering. Actually, it wasn't really in the title and thumbnail, but as you guys can tell, let's say by the title and thumbnail, today I'm going to be working with more Scikit-Learn under the category of clustering, where I'm going to go over, it was something like K. I forgot the name. K means, and I forgot the second topic. What the hell? Hold on, let me just go to my gameplay screen. Yeah, it's hard to memorize these names, like what the hell? Because last stream, I did work a little bit with K-means, but I did not complete it because I had an exam today. But today I will be having way more time than I had yesterday. So if I had time, I will work with database scan as well once I'm done with K-means. If not, I'll just complete K-means. But I do need to work on, let's say, dimensionality reduction and model evaluation before I work on my second mini project. Okay, that said, I will be working on with a 25 to 5 minutes Pomodoro timer, where every 5 minutes, actually every, let's say, 425 minutes, I get a 15 minutes break. Starting in 3, 2, 1, and let's go! Okay, and this is a brand new classes chat, so let's say something like, let's say, live exclamation. There we go. And yeah, I will be touch typing as well. Okay, let's see. There it is, let's go. You left me hanging on a real question last time. Yeah, I did, because I had to, like, leave. Not a warm up, straight back to it. Straight back into it. How you hiding, Pixel? Appreciate you joining the stream. Okay, you already know inertia keeps dropping no matter what, all the way till 0. If you let K run wild, so lowest inertia is a trap. That's not new to you. Here's the question again, and I want you to actually sit in it before you answer. If you plotted inertia on the x-axis and K on the x-axis, K equals to 1, K equals to 2, K equals to 3, going up, what would that line look like? And somewhere in that line, there's a sign that tells you past this point, you're not finding real structure anymore. You're just slicing air. What would that signal look like on the chart? Okay, let me say something like, sensei, I did not read, the explanation, that you gave me before the question. Therefore, can you re-explain it to me? Okay, guys, and my fingers are not warmed up yet, so ignore a few typos. That's it, I'm just gonna go ahead and fix my typos real quick, add a period here, and let's send it. There we go. Okay, let's see. Good catch flagging that instead of faking through it. That's exactly the instinct I want from you. Here's the full picture laid out clean. What you already know, restated. Inertia equals to sum of squared distances from every point to its own centroid. Is that how you pronounce it, centroid? Okay, inertia equals to sum of squared distances from every point to its own centroid, okay? Low inertia, tight, well-packed clusters. High inertia, scattered, loose clusters. As K goes up, inertia mechanically goes down, always, no exceptions. Why? Because more clusters equals to more centroids. Every point is closer to some centroid. Push it to the extreme, K equals to number of data. K equals to number of data points. Every point is its own centroid. Distance equals to 0. Inertia equals to 0. So here's the actual problem you're solving. You can just pick whatever K gives lowest inertia. That's always going to tell you more clusters, more clusters, more clusters, all the way up to a useless answer. Every single point being its own cluster tells you nothing, but inertia dropping isn't meaningless either. Think of what's happening in the early clusters versus the late ones. Say your data actually has three real obvious clumps in it, like your coffee shop example, but three types of customers instead of two. Going from K1 to K2, you're splitting one giant blob into two real groups. Inertia drops a lot. Real structures is being found. Going from 2 to 3, going from K2 to K3, same thing, you're finding a third real group. Inertia drops a lot again. Going from K3 equals to K4, there is a fourth real group. You're just slicing one of the three real groups in half of no reason. Inertia still drops because more centroids always helps mechanical, but only drops a little. K4 to K5, K5 to K6, same story, smaller and smaller. Diminishing returns, so the shape of the curves is signal big drops while you're finding real groups. Then a curve goes flattish, small drops once you're just cutting real groups into meaningless pieces. Now, with that said out loud, alright, I got a nice question for this. I have a question about what you asked, or what you just explained. There we go. So apparently, so when we slice, does it slice across the entire data, or just slice an already sliced piece? Okay, I'm gonna go with something like, for example, okay, let's go with something like, for example, this is going to be a colon. There we go. For example, let's say something like data is going to be equal to, I'm gonna go with 1, 2, 3, 4, 5, 6, 7, 8, 9. I cut the data once and go from k equals to 2 to, actually k equals to 1 to k equals to 2. Okay, and then we're gonna go with something like my data is gonna be equal to, how many hyphens were here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm gonna go with 10, and even 10 hyphens. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I cut the data, or let's say I slice the data even more and go from K2 to K equals to 3. Then I'm gonna go with, let's say, something like data is gonna be equal to, this time we're gonna go with 1, 2, 3, 4, 5, space, 1, 2, space, 1, 2. Okay, this is gonna be, um, there we go. I just somehow cut it in half. Pretend, each slice was 2.5. Okay, rather than 2 and 3. Okay, there we go. This is going to be slice. And then let's go with something like, and so on, dot, dot, dot. However, or did you mean that going from, let's say, or did you mean that going from k equals to 1 to k equals to 2 to k equals to 3 means that the data is sliced evenly across the entire data set. There we go. Let's go with evenly something like, I'm gonna go with something like data is gonna be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm gonna go with data is gonna be equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we're gonna go with data is gonna be equal to, okay, what is half? So what is 10 divided by 3? Wait a damn minute. Let me grab my calculator up here. 10 divided by 3 is going to be 3.33. Okay. 1, 2, 3, 1, 2, 3, 1, 2, 3. What is 10 divided by 4 again? Let's go with something like 10 divided by 4 is 2.5. Okay. Pretend each slice is 3.33. Okay, and then I'm gonna go with something like data again for the last time. This time I'm gonna go with something like data equals to 1, 2, 1, 2, 1, 2, 1, 2. And this is gonna be 2, 4, 6, 8, 1, 2. Wait, that is 10, right? So 2, 4, 6, 8, 10. Okay, and finally, can I get a real world example as well that makes it easy for okay, I'll just send it. I forgot I had a period, but that's fine. Strong question, and this is exactly the kind of thing you should be stopping to ask about because the answer isn't either of those two. And glossing past, it would have costed you later. Neither picture is quite right. Here's why. K-means doesn't slice the data by cutting into even pieces at all, and it doesn't necessarily recut one existing piece either. Every single time you change K, the algorithm starts over completely, refresh, and runs the full loop again from scratch. When in the genuine world was I going to be told that? But hey, it's fine. Drop K random centroids. Every point joins its nearest centroid. Move each centroid to the average of its group. Repeat until stable. So K equals to 3 is not K equals to 2, but with one extra cut, it's a totally independent run that happens to use 3 centroids instead of 2 centroids. The algorithm has zero memory of what K equals to 2 looked like. Now, where do the clusters actually land? That depends entirely on where the real structure in the data is, which is why your second guess, even uniform slicing, is closer to correct behavior, but only when there isn't a real structure left to find. Let me show you both cases with your dash example. Say your real data has 3 clumps. Bro, we can learn AI engineering without machine learning and deep learning? Can we learn AI engineering without machine learning or deep learning? I do not think that we can, to be honest, because in order to know how do you work with AIs and like AI engineering, I think that you really do need to understand machine learning and deep learning at, let's say, even at a very basic level, if not like really advanced level and all that stuff. And also, the roadmap that I am currently using for my AI engineering for 365 days, even though I am not focused on building or training models myself or doing whatever deep learning tells me to do, I still have 2 dedicated phases, one for classic machine learning and the other for deep learning right after each other. But then after that, I work with, let's say, transformer architecture, RAG, which is really important for AI engineering, and then hybrid search and re-ranking and all that basic stuff, graph RAG, RAGs, RAG evaluation, blah, 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 and running local LLMs. But yeah, looking at this, I am using oh wow. Okay, you definitely need machine learning. If you see a topic comes twice in this roadmap, which definitely means that that is important for AI engineering. Because this roadmap is morely focused on building a fully autonomous AI, or like not building, augmenting a fully autonomous AI, which I could do using LLMs as well. But yeah, that was way off the question. I think that you definitely need a deep learning to a certain level, but machine learning, let's say, you wouldn't have to master it and know like and be like, let's say, a math genius or a math wizard, but you would still know what it does and how would you really use it. I don't really know about the using part. Fact check me on the using part, but then you would really know all three. I mean, you would really need both those topics to like let's say be an AI engineer. Oh god, that was the most confusingest way to phrase it. That's it. Now, where do the new clusters actually land? That depends entirely on where the real structure in the data is, which is why your second guess, even uniform slicing, is closer to correct behavior, but only when there isn't a real structure left to find. Let me show you both cases with your dash examples. Say your real data has three true clumps. Data equals to 3 clumps. Gaps between them, a real structure. K1, one centroid, sits in the middle. Inertia is huge. Everything is far from one center. K2, two centroids will land where? Right in the middle of two of those real clumps, because that's where the algorithm can minimize distance the most. Big inertia drop. K3, three centroids, one per real clump. Perfect fit. Huge inertia drop from K2. K4, now there's no fourth real clump left. The algorithm still has to place a fourth centroid somewhere. And here's where your first question comes in. It'll usually chop through the middle of one of the three data clumps, splitting it roughly evenly, because that's the only way to reduce distance, even a little small inertia drop. So, early on, K below the true number of clusters, it's finding real separate groups. Once you go past the true number, it starts cutting into existing groups because there is nothing else left to find. Your first drawing describes what happens after the elbow. Your second drawing, even slicing, describes what k-means does when there is no real structure left to discover at all. Real world example, no coffee shop this time. Let's use something totally different. T-shirt slicing. Imagine you have 1,000 customers' heights, no labels, just raw numbers. In reality, most humans cluster into a few real body size and groups. Can you share the roadmap? Actually, yeah, if you guys do, let's say, join my Discord server and either go to, let's say, the Coding Helps Us chat, general chat, or the Python chat, mention my name there asking me for the roadmap. I will be DMing it to you guys personally as soon as the stream is over. And you guys can get access to my Discord server or, let's say, any of my socials in general through the link in the description of this stream, through my bio, or by typing, you know what's great, let's just go in the stream. Or by typing exclamation Discord on chat, all lowercase, no space. A link should pop up within 3 to 4 seconds. That said, that's pretty much it. And then after the stream, I will be DMing you guys, or I will be DMing you the roadmap. Okay, that's it. Imagine you have 1,000 customers' heights, no labels, just raw numbers. In reality, most humans cluster into a few real body size groups. K1, everyone gets one size. Terrible fit. Huge inertia. A 5'2" person and a 6'5" person, both squeezed into the same box. K3, you find SML, small, medium, large. This matches real human height distribution. Everyone gets one size. Oh, I see. Okay. So K1, everyone gets one size. Terrible fit. K3, small, medium, large. This matches real human distribution. There are legitimately 3 dense clumps into the data big group. K equals to 5, extra small, medium, large, extra large. Still real, humans do separate out that much. Still a decent drop. K20, now you're inventing sizes like M and a quarter inch. There's no real 20-way clumping in human height. You're just slicing the M group, which is the medium group, into 4 fake subgroups because the algorithm has no place central. Because the algorithm has To place centroid somewhere, barely any inertia improvement from a lot of added complexity. That k equal to 20 helps, but k equals to 3 to k equals to 5 genuinely help. Is exactly the signal you're hunting for on the chart. Now back to the original question with all of this now in your hands. On an inertia versus k-line chart, what shape does that curve take? And where on it would you actually put your finger and say, this is the right k? Where is the chart again? Was the chart last stream or like when? No chart been showing. I described you the curve in words. I didn't draw it. Oh, you're kidding me. I'm going to reach my limit so much faster if Claude literally gave me a chart. Oh, hell no. Okay, you know what? Fine. Okay, fair to ask for straight up rather than guessing at what I meant. Let me actually put it in front of you. That's the exact chart shape from t-shirt example plotted as real numbers so you can see it rather than just hear it. Look at where the drop steeps versus where it goes shallow. That's definitely the shallow. Bro, Claude is such a freaking insane AI to do all this stuff. Okay, now back to the question that's been sitting since before you paused. Where on that curve would you actually put your finger and say this is my K, and you would want to call that bendy spot in the line? Okay, I would say something like 3, because okay, curve, right? So back to the original question, with all of this now in your hand on an inertia versus line. Okay, so from 100 to 3 is a huge difference. 4 is actually a huge difference as well, but then after 4, it's like, it's barely any difference, to be honest. I would say 4, because there is a huge inertia drop from 100 to 4. Actually, from 100 to 20, my bad, not 4. Would say 20 because there's a huge inertia drop from 100 to 20, which is also 4 in the number line in the k means. Okay. And that everything after 4 makes just a slight bit of improvement. Okay, and hold on, let me fix my typo real quick. What the hell? A low inertia drop. And then I'm just gonna go ahead and send it. That's pretty much it. Okay, and I'm also gonna open Wuthering Waves because my timer is almost off. I mean, my timer is almost done and I play Wuthering Waves in my break. That, sir, you're pointing at the right spot on the chart. K equals to 4 is correct. Nice eye, but you tangled up two different things when you said, I would say 20. Let's untangle it cleanly. 20 is an inertia value. It lives on the y-axis. It's not a K. It's how tight the clusters are at that point. 4 is the K value. It lives on the axis. It's the number of clusters. So the correct answer, stated properly, is K equals to 4 is where you put your finger, not 20. 20 is just the inertia reading you happen to see at the point. It's not what you're choosing how many clusters, not how low the inertia number is. Now, your reasoning for picking that spot is exactly right, and I want you to hear that clearly. Huge drop from K equals to 1 to K equals to 4, 100, down to 20, then everything past K equals to 4 is shallow improvement. There we go. I'm just gonna grab my Wuthering Waves up there just so I can switch later on. Okay, your reasoning is right. Quick check before I move on. Say it back cleanly. What's the K value where the curve bends from steep to shallow, and what's the inertia value at some point? 2 separate numbers, 2 axes. And what's the inertia number point? Okay, so k equals to 4, and the inertia number point is 20. And then we're gonna send it. I forgot any period, but that's fine. Clean, that's exactly right. I'm not gonna read all that. Okay, that bend where steep turns shallow has a name. It's called the elbow method. Oh wow, I didn't know about that. So where it turns shallow, it's called the elbow method because the curve visually looks like a bent arm, and that elbow is that joint where it kinks from a steep drop to a flat tail. You just found it yourself before I even gave you the word for it. Quick gut check before we move to real code. Why do you think it's called an elbow specifically rather than something else? Look at the shape you just described, steep then bent, because the curve resembles an elbow like shape. That's literally the most basic thing that I could freaking say. Exactly, bro. What else could I say there? What the hell? Okay, you've now got the full concept. No labels, distance-based grouping, the centroid loop, why the inertia always drops, and now the elbow method for picking K without getting fooled by that mechanical drop. That's the entire conceptual half of clustering, done and mostly self-derived by you. Now we go hands-on. Time to actually run K-means for real. Quick check for that rule. Have you ever used? I have not. Let me just go with something like I have not. It's so predictable. It's so predictable what Claude is going to ask me because I told it to ask me this. Okay, good. Full teach, no assumptions. Here's the syntax piece by piece before we touch any code. That's time. Hands off anything that is distracting.
I have the key to solving this
That is not
question.
distracting, I mean. Back to Wuthering Waves. There we go. And yeah, last stream I was about to talk with Yang, but I ended the stream because I had to go and study for exam. Today we're gonna do that. Oh, come on, hold on. Let me get the timer here. There we go. I'm just gonna decrease my timer a bit. Bro, have you
I've been
noticed?
seeing these black petals for a while now. They're scattered all over the place. I'm pretty sure they're not made by Miss Verena. The streams have been disrupted. Someone
Leave it-
has been following us.
Leave it to me. You two should head back to the city. Go with that.
Rover, are you sure you want us to leave? It could be dangerous for you.
Trust me, I got this.
Okay. Tricia and I will wear these black flowers and go look for members of the Black Shores in the city. Rover, please be careful. Ring us anytime when you need help.
Alright, so locate where the sound is coming from. Can I please use my scooter? Investigate. I'm done with investigating, right? I'm gonna get all these freebies. I cannot use my bike. Are you kidding me? But from the garage, by God, we're getting like a lot of good
The
stuff.
Fraxidus. What are they doing in a place like this?
Who's that? Oh my God!
Damn that
Defeating-
woman. Always getting in our way. And what are you doing here? Get lost.
I'll have to
Bro,
take them
Rebecca
down
is such a
first.
freaking tank. Not a tank. She's such a freaking damage dealer. What the hell? Eat lead.
There, goodbye!
Talk about a freaking beast.
Time to get bud!
I don't even need to switch to anyone
The
else.
weird
She's just
noises
that good.
persist. They're coming after me.
Find a suitable place to lure out your stalker. Interesting. I'm so glad I got. Oh wait, what's that? What's that? Whoa, 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 whoa. What's that? I saw something colorful.
Here we go.
Okay, is this something good that I can use? Because we can make a lot of food with these things. Whoa, what are these? Oh, wow. Alright, guys, my headphone officially ran out of charge. Let me check if you guys can actually hear me when I play some desktop audio. You guys cannot hear me anymore. Oh god, I forgot to freaking charge my headphones. I don't know from where is my audio coming now. High definition, NVIDIA high definition from BenQ, or there we go. Wait a minute. I'm trying to find from where you guys can hear my desktop audio now. Is it coming from this? There we go. Alright, I guess I don't need this light. I'm gonna just charge my headphones, which I should have done before stream. That's alright. Okay, now let's move on. Wow, I just realized without my headphones I sound way too loud. Right. Moving on. I wonder if there's like fall damage. Wait, I gotta go up? I gotta go higher? Are you kidding me? Wait a minute. Okay, I'm gonna recover some stamina, and then we're gonna march higher. Just realized I got a headphone then. Hey, let's chop. Yeah, I won't be going completely close to it because I'm oh god. No. Alright, is there another way? Okay, I'm gonna move on to my tank. She's
Let's
tanky.
take it slow.
Well, let's take it slow. Will I make it? Yep, just stay slow. Oh, he's so much damn. Alright. I think I'm gonna go. Oh wow, this is a much better place to go from. Wait. Is this all free stuff here? Okay, that's it. That's time. Hands off anything that is distracting. Moving on. Back to work. Let's grab my cloud here. There we go. I'm gonna get my timer up there. Hopefully my headphones is gonna charge by the time I'm done. That said, good to know. Full teach, no assumptions. Here's the syntax. Piece by piece, before you touch any code, the import from Scikit-Learn.cluster. I want to import k-means. Okay, that makes sense. Same pattern as SVC. Scikit-Learn.clusters is the submodule. K-means is the class inside it. Create the model equals to k-means, which requires a parameter of n underscore clusters that is going to be equal to 4. N underscore clusters is just k, the number of the clusters you're telling it to find. That's the one thing you decided up front, same way you decided kernel equals to or C equals to for SVM. Kernel equals to linear and C equals to, let's say, 1,000 or like 0.00001 for like, let's say, a high weight or a low weight. There we go. Okay, fitting it. Model.fit, the generic method used to train my model, but this time, unlike always, just requires one parameter of x. That's strange. Okay, notice something important here? No, why? That's exactly what I was just saying. Every single method you've touched before this, linear slash logistics slash ridge regression, decision trees, random forest, SVMs, called .fit xy, x and y together because they all had labels to learn from. Clustering has no labels, so .fit only takes x. That's not a typo you'll make later, that's the whole no label concept from earlier showing up directly in the syntax. After fitting, 3 things you can pull out. Model.cluster, underscore centers, underscore, the final resetting position of the centroids, the average of its group position from step 3 of the loop. After the loop finishes, repeating model.labels underscore which cluster 0, 1, 2, 3. Each point in your original x got assigned to in the same order as x. Model.inertia underscore the same inertia number for this fitted model, the same value you'd plot on that chart. Okay, you look before I hand you an exercise. Say it back to me in your own words. Why does fit only take x and not xy? Okay, tying it back to what makes clustering different from everything else you've learned. Because x is a data type, while y is usually the prediction that we explicitly okay, y is the prediction that we explicitly specify to our let's go with something like, I don't know, explicitly specify to our model. However, can you, let's say, re-explain? Oh god, are you kidding me? Can you re-explain this part to me, question mark? Okay, and then I guess let's go ahead and send it. Good catching, good cat. Stopping instead of forcing it through. That phrasing you gave us has the right instinct buried in, but it's a little loose, so let's rebuild it clean. We explained from the ground up. Every method before clustering was supervised, meaning you gave the model the correct answers up front and learned by comparing its guesses against those answers. Think back to decision trees or random forests. You hand X, temp weather, and Y played outside, yes/no. The model's whole job during .fit was to figure out a pattern that maps X to Y because you handed it Y. Wuthering Waves, actually, yeah, I am working on, let's say, machine learning, but I am also following a Pomodoro's timer, which I did realize helps me focus even more, because back in the days when I used to just constantly work for a whole hour, I used to get really exhausted, but these days I work with 25 minutes of, let's say, programming, or let's say learning machine learning, or the prerequisites required for AI engineering, and every 25 minutes I get a 5 minutes break where I play Wuthering Waves, and let's say every 4 sessions of 25 minutes, I get a 15 minutes break where I again do play Wuthering Waves. I could do anything, but I play Wuthering Waves because it gives me content for my gaming channel, and it's kind of fun, to be honest. That's the the real correct outcome for every row. That's what supervised means. A supervisor, you via the dataset, is still standing over its shoulders saying, here's the right answers for this one. Oh damn, that's so good. Honestly, it does sound kind of cool. Also, because I get a lot of content. Like, by God, I have scheduled videos until August 22 in my gaming channel. But yeah, I haven't edited much videos because I had an exam today, and like I had one yesterday as well. But from today on, I have way more time than I would have usually had. Maybe from like the 8th. Okay, clustering is unsupervised, so everything up till now has been supervised. We gave it our dataset and told it what pattern to follow, while the fit method was really recognizing those patterns. However, clustering is unsupervised. There is no right answer behind being handed over. You give it only X raw numbers, no outcome column at all, and say, I don't know what group exists in here. You figure out the groupings. There's no Y to check against because nobody labeled the data with this one belongs to group A ahead of time. That's the literal reason the method is called unsupervised. No supervisor, no answer key. So when .fit method runs with no Y, it's not a shortcut or a simplification. It's because a Y doesn't exist for this problem. You can't pass something that was never there. Now try it again in your own words. Why does .fit only take X here? Tied back to supervised versus unsupervised. Because unlike everything that I have worked on so far, let's go with something like on so far. It's not addictive and you don't need to pay much attention to game, unlike FPS type games or story mode. That's what I'm saying exactly. There are like a few should I say cutscenes that go on for like really long. The longest that one cutscene went for was 25 minutes. That's kind of annoying at times, but mostly it's just like an open world exploring game and like completing quests. So that's why it's not really as addicting as well, and it does not really require much attention. Okay, that said, because unlike everything that I worked on so far, such as regressions, and let's say something like decision trees. Clustering is which have been supervised, which have been supervised. Clustering has not been supervised. Clustering is not supervised. Therefore, I do not need. Therefore, its fit method. Its fit method does not require a parameter to conclude an answer. Okay, there we go. Oh god, guys, it's so hard to phrase new topics that we have worked from. There we go, parameters, and then let's go ahead and send it. Okay, let's see. That's it, you've got it. Supervised equals to answer keys exist. A model checks its work against it. Unsupervised equals to no answer key exists. Model just finds structure on its own. Dot fit x with no y isn't a shortcut. It's the honest reflection of there's nothing to check against. Now, let's put that information in your hands. Here's your exercise. Don't run anything yet. Just build the dataset and predict first. The task. Build a small dataset of 6 points, one-dimensional, just like your very first number in number line exercise. Okay, so one-dimensional. That has two obvious clumps in it. You pick the actual numbers, just make sure there's a clear tight group and another clear tight group, and with a wide gap between them. Then import k-means, create a model with n underscore clusters equal to 2, fit in your data, print model dot cluster underscore centers underscore model dot labels underscore model dot inertia underscore. Before you run it, predict in writing all three of these. What do you expect clustering underscore centers underscore to roughly be? Hint, tie back to what centroid actually is, the average of its groups. What do you expect labels to look like for your 6 points? Do you expect inertia to be small number or a large number, given your clumps are tight? I'm assuming a large number because there's going to be a massive cut from the center. I sometimes open your stream side by side when I'm studying, so lol, I don't feel low, and guys, it actually sounds really, really cool. It actually kind of gives me company too, I can't lie. I don't have college for now, so I just crashed in after a long time. Keep it up, man. Hope everything goes well. Yeah, appreciate you. Smart, is there a pronounce your name? Whatchamacallit? Good luck with your college. Well, hope everything goes well for you too. That is the most awkwardest thing I've said. But then, I had a quick little question. I wanted to see the data here. So apparently I gotta replicate this data, but I'm assuming I'm gonna have a list of numbers or a list of numbers as opposed to just a regular list of numbers, even though it is supposed to be one dimensional. A list of something is technically considered two dimensional. So I think I just need a list of numbers where I'm going to go with 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. And then I'm going to cut clusters from it. All right, so apparently I'm going to grab this reference in the other window. Wait, where in the there we go. Okay, and then we're going to grab our Visual Studio Code out. I'm going to exit my calculator because I highly doubt I'm going to need it. And then once I'm done with my calculator, I'm gonna go ahead and let's say create a brand new file because we are working with a brand new topic here. There, I'm gonna go ahead and name this something like k hyphen means. Does that sound good? K means, now go with hyphen. K means.py. ph, there we go. Now in my k-means.py, first things first, I'm gonna go ahead and import something from something. So from sklearn dot clusters, this is the class's name. I want to import an instance of a class called k-means. Okay, I need to be sure that this was the name though, but I'm gonna fact check that later. And then we're gonna go ahead and create a data called x, which is just gonna be a list of numbers. I'm not gonna go with a list of numbers as I usually have been doing, because I don't think that's compulsory here. And this is technically one-dimensional, just a regular list of numbers. Two-dimensional would be something like this, like having a bunch of numbers here, having a bunch of numbers here, and all those things. However, for the time being, I'm gonna go with something like, let's say 100, and then, I don't know, 90, 80, 70, 60, 50, 40, 30, 20, 10. And that's about it. Can you explain what are you learning today? Try to keep it short. So basically, I'm working with, let's say, a topic under my roadmaps is classic machine learning section under the category of, let's say, Scikit-Learn, where I'm currently working on a subcategory under the category of Scikit-Learn called k-means, which comes under clustering. Right here, there we go. So pandas, polars, there we go. So I'm currently working k-means, which is a topic under my phase 2. And the second last topic to my second last category as well, to be honest, where basically what k-means actually does is that it cuts my data. For example, I've got a massive data, but let's say that one massive data, for example, of, let me give an example of like t-shirts. If everyone uses that same exact data, there are like 100 t-shirts and every single t-shirt is of the same exact size. People are not all the same exact size, so that people won't be satisfied with that data. Therefore, let's say the t-shirts are going to be uncomfortable, but using k-means, quote unquote, I could go ahead and, let's say, set my k underscore clusters, the number of clusters slash groups I want in those 1,000 t-shirt, to have like different categories of, let's say, sizes. If I were to set it to be 3, then my one massive pile of groups, which all the clothes sizes were exactly the same, is going to be cut into 3 separate groups, where one group could be small, the other group could be medium, and the other group could be large. Those are the 3 different sizes of clothes. But if I set the clusters to, let's say, something like 5 rather than 3, I'm going to be adding 5 total cuts in my entire data set, where there could be an extra small, a small, medium, large, extra large. If that made sense, the people get more options, but then the inertia, which is basically the amount of drop, like from all clothes being the same size to having 3 different categories of clothes, the inertia dropped a lot, because that helped improve the data significantly. But adding 5 cuts, sure, it helped it a bit more, because someone could be like extra small, someone could require an extra large t-shirt. Although if my k-means was set to, let's say, 20 rather than 5, 20 different group categories is going to be, let's say, an extra small quarter, extra large quarter, that inertia is going to drop really, really less, which is not going to be as helpful. That is basically what I was literally working on, but with an actual data as an example. Oh, seems fun. It actually is kind of fun. It's really hard to explain it though, because I am still just working on it, but the explanation that I did give was correct. Okay, that said, let me read the instructions. So once I'm done creating a data, let me just go ahead and grab Claude here. The next thing that I need to do is to build a data set of 6 points, one-dimensional. Wait, hold on a damn minute. 6 points means I need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, we're gonna remove the 2 of these. Isn't 60 supposed to be 6? 10, 20, 30, 40, 50, 60. Okay, makes sense, makes sense. Okay, so I have 6 data points. And then after I get those 6 data points, just like your very first number line exercise that has 2 obvious clumps in it, where I think it's like 130, 100 is one clump and 30 is the other clump. Import the, not 30. 80 is the, nope, between 70 and 80. There we go. So this center line is a clump. That is one category. That is the other category. Okay, and then let's grab plot here again, where we have two clear clumps, a group, and another group. Import k-means, which I did, create a model with n underscore clusters equal to 2, fit it in your data, print model dot clusters underscore center underscore model dot labels underscore and model dot inertia. Inertia is going to be huge. Okay, so I'm gonna go ahead and let's say create a models variable that is going to be equal to my k-means. This is a pattern that I have been using this entire machine learning this section, where I'm gonna go with something like n underscore clusters that is equal to 2, because I want my k, the example that I was giving of cut in center 3, 5, and 20, I want to set it to be 2 because I want two groups. That's fine, I understand it. You explained it in a really good way. I'm not a newbie, so I get it. Oh, I see. Okay, and then once I'm done with that, fit it in your data. So fit is basically a model that we call, so I'm gonna go with something like, okay, this is supposed to be model, not models. Okay, so I'm gonna go with models.thefit method, which is a generic method that we use to train our, let's say, data that which we use to train our model. There we go. Okay, which requires data as a parameter. However, we won't need a prediction because clustering does not predict. It's an unsupervised class. Okay, and then print model.cluster underscore centers. So I'm gonna go ahead and print. Let's go with something like my model. There we go, dot cluster underscore centers. I'm assuming that my centers is basically the centroid, which is going to return 2 because my model has been cut, or my data has been cut into 2 cluster of groups. And then we're gonna go ahead and let's say print our model dot labels. Okay, I don't know what the labels does. I need to reread that explanation. And in case you guys are confused what the underscore is about, basically the reason we use the underscore is so our data types here, not data types, so our instances of whatever these things are called. In classes we call this the self dot something something. I think it's called data types only. Yeah, so our data types does not really conflict with any of Python's literal keywords or yeah, keywords. Okay, and then I'm gonna go with something like model dot. Wait, this is gonna be labels. Okay, and then we're gonna go with something like model dot inertia underscore. There we go. Okay, now that's pretty much it. But before I really run it, Claude asked me to predict what am I going to be getting. So we're going to go up here just to the explanation. Model.cluster underscore center, the final resting position of the centroid is the average of its group position from 3 steps of the loop after the loop finished repeating. Okay, so model.clusters, if it's the average, I'm going to go with model.cluster underscore centers underscore is going to be equal to, okay, let's see, it's going to be equal to my average of both groups, which is let's say something like, okay, I'm awful at math here, so we gotta go with 100 plus 90 plus 80. That is equal to 190, 200, 270. 270 divided by 3. That is equal to, I think you made some mistake. Wait, did I? Okay, wait, let me go with 270 divided by 3. That is 90. Okay, so the first is going to be 90. And the second group is going to be the same, but with the average of different data. The second cluster. Oh god, there we go. Okay, line 1 from Scikit-Learn.import k-means fix the submodule name is pluralized incorrectly. It must be Scikit-Learn.cluster. Oh, I see. Yeah, it is cluster. Oh god, how do you guys notice that stuff? And k-mean, is the k-mean? Okay, it's k-means. There we go. Okay, guys, I'm so shocked. How do you guys pay attention to that? Like, I imported and I thought that I just did that part correct. When I get an error, if I get an error where it says my import line is wrong, that's when I really pay attention to that. Okay, that's it. Let's see. And for the second prediction, my model.labels model dot labels underscore, which is the cluster each point in an original x got assigned to in the same order as x, is going to be 2. Okay, and lastly, model.inertia, the single inertia number for this fitted model, the same value you'd plot in your chart. Inertia value is gonna be is going to be 2 as well. Because let's be honest, I cut my model in half. Wait. I forgot. Control A, Control C. I'm gonna copy that. The predictions that I gave may not be accurate since oh god, there we go. Since I just read about them once and did not get any hands on practice. That's it. Hands off anything that is distracting. Time's up. Break time's here. Back to work. You need to reshape the data or structure it as a list. Okay, I knew that, but Claude said that it's supposed to be like one dimensional. I gotta ask that. Misspelled attribute nameline 8 print model cluster.center. Fix the fixed attribute is pluralized and ends with an underscore. It must be model.clusters._center_. Okay, no, that is correct. I need to add that underscore. Okay, that said, find a suitable place to lure out your stalkers. So apparently we were trying to climb up while spamming a bunch of F's because I need to get I want to get my free stuff. Can I not? Oh, you're kidding me. I cannot run off the waterfall. Darn it. There. Oh. I'm gonna just wait. Okay, let's recover a little. I'm getting closer. I think I could run that high once my stamina is on. Okay, hold on. There we go. Alright, perfect. So apparently I need to go to the right. There we go. Right here. I'm gonna wait for my stamina and then we're gonna run back up. And there, I'll lure my stalker in here. Are those peaches? Wait, is that an event going on right now? Is this like... Oh, I wanted the peaches. Are they trampoline?
If I climb up to that point, I should be able to get behind that person.
Wait, two minutes. Wow. Alright, I got 2 minutes.
Conception.
I'm pretty sure I missed one, but I guess we got it. There we go. Okay, I'm gonna be behind that person
Better
now.
hide here for now.
Rower's powerful character too, is he? I thought that his skills weren't as strong. Is he like, a character that can grow stronger over time? Okay, better hide here for now. I wonder if my headphones is charged. There we go. I love the animation. Oh! Is that a tacit? Oh! Wait, is she a resonator? Is she like a new strong resonator? Was that a tacit discard? She killed that.
Looking for me?
The rose in the head, the black rose.
Oh.
see the right upgraded weapon. Oh, I see. Oh wow! What the hell? Oh, that was. Oh. I'm just gonna be quiet.
You're such a box full of surprises.
Who are you? Why are you following me? I'm gonna go with who are you?
So we're playing Truth or Dare now. I see. Oops. Getting angry, are we? Sorry, but it's just so much fun to rile you up.
I won't give you spoilers, lol. It has a fun story. It actually does.
You're the very first person to pique my interest like this. You have great potential.
And let me know if you guys can actually hear the audio, because apparently I don't have my headphones on right now, so I can't tell you if you guys can actually hear it. I forgot to read what he said. Damn it.
Okay, so you're not up for small talk. I'll keep that in mind. You're my mission target after all.
Are you from the Black Shores?
Bingo! I'm one of the bloom bearers of the Black Shores.
Oh, I thought it was a leader. Never mind, they're just a member.
This Blake bloom is our symbol. It represents our mission to save the world. That's what it says in the rules, at least.
What are you planning to do with me?
Our plans. What is it again? To recruit as many talents as we can and save the world from its impending doom.
Okay, that's time. Hands off anything that is distracting. Back to work, back to work. There we go. Let me grab the timer up here real quick. We'll continue that. I'm glad it didn't stop in a cutscene. You won't ever see a nerd like me who plays every single type of genre in the game and also study like crazy. You know what? Actually, that is pretty rare. It's like huge respect, bro. Okay, do you come from? Do I come from? Okay, that's it. Stop before you even run this. There is a real problem here. Good thing that you flagged low confidence, but let's fix the actual issue, not just hand wave past them. This is exactly the kind of thing Sensei catches before you burn a run on it. Problem 1, your dataset has no gap, 190. I thought Claude said one-dimensional. I was gonna go with a list of lists. Walk that number line, 100 to 90 is a gap of 10 and of 10.90. Of 10, 90 to 80 is a gap of 10. Every single gap is 10. This is a straight line, evenly paced, not two clumps with, oh, so it had to be two lists. Okay, that makes sense. Wuthering Waves is short for Wuthering Waves? Oh yeah, Wuba is short for Wuthering Waves. That makes sense, yeah. Okay, go back to your very first clustering exercise. You had tight groups like 3, 4, 5, 6, separated by a wide gap, 35, 36, 37, 38 from another tight group. This dataset has no wide gap anywhere. Fix this before running anything. Problem 2, cluster underscore centers underscore prediction. Your math 270 divided by 3 equals to 90 is a fine averaging calculation, but it's built on your broken dataset, so it doesn't mean anything yet. Once you fix the dataset with real gap, redo this prediction using the actual two groups you pick. Problem 3, labels underscore. Prediction 2 is not what this returns. Think back to what I told you labels underscore actually is. Which cluster each point in X got assigned to in the same order as X. Was asking if that was it. I've only played PGR and art style looked similar. Oh, actually, the game that I'm playing here is an RP. I'm pretty sure it's an RPG game. It's called Wuthering Waves. It's a gacha game. Wait, actually, never mind when I said RPG. RPG stands for a role-playing game, right? Okay, I mean, I think this is a role-playing game. I'm role-playing as Rover here. Okay, that's it. You have 6 points in X label underscore. Will have 6 values in it. 1 per point, not a single number. Each value will either be zeros or ones since K2 only. Oh, so labels basically labels everything as zeros and ones. Since K2 only two clusters, IDs exist 0 and 1. Something like 0, 0, 0, 1, 1, 1. That's the shape of what you're predicting, not a single 2. Problem 4, inertia prediction. 2 is almost certainly wrong, and here's why. To think about it, not just accept it. Inertia is a sum of squared distances. I absolutely forgot about that. Squared even small distances, 1 squared and summed across 6 points tend to produce a real number, not something as small as 2. Once you have a real data set with real gaps, think about roughly how far each point sits from its own centroid. Square that and add up all 6. That'll give you... Okay, that'll get you in the right ballpark, not just guess a small number because it feels tidy. Fix the data set first, then redo all 3 predictions grounded in the correct numbers. Send back that's sent back before you run anything, okay? I guess I'm gonna grab my Visual Studio real quick. It's a gotcha. Punishing Grey Raven as similarly fighting style. I see. Okay, so first things first, I'm gonna fix my one of my errors. This is going to be a list and that is going to be a list. Apparently, this is still one-dimensional. It's not really two-dimensional. I don't get why, because apparently this is how two-dimensionals really work, because they're just basically like this. But since I'm predicting something like this goes, I think I'm going to ask why later on. Okay, but then for now, model.clusters, that's pretty much it. This is centers, that's labels, inertia. Okay, I'm going to go with control and backslash. Claude would never know I ran this. Okay, so first things first, I'm going to change my directory to, let's say, Scikit-Learn. Let's go with something like Scikit-Learn. Okay, because I want to kind of learn from my output as well. Cannot find path. Scikit-Learn. Oh, I wrote Slit-Learn. Hold on. I'm gonna clean my directory real quick. Okay, now let me change my directory to Scikit-Learn. Okay, and I'm gonna go ahead and manually run my file, which is called kmeans.py. Okay, now once it runs, I'm gonna see my output real quick. Hold on. I guess while I wait for it to run, I'm gonna drink some water. You gotta be hydrated. When was the last time you guys drank some water? Interesting. Okay, let me say it was hard to... Okay, I'm actually gonna send this to Claude this time. I'm gonna go with Control-A, Control-C, grab Claude out, share, paste it, and then go with something like output. And then I'm gonna go ahead and, let's say, paste my output as well. There we go. And then let me say something like Sensei. I ran the code because it was hard to visualize what output would I get without ever seeing it even once. However, now that I saw it, I believe that it feels different from what you were telling me to think about. Either that or I am, let's say, something like too dense to understand the output. Okay, I am getting way better at touch typing, but I still slip up here and there. Okay, I'm gonna go sleep. It's 2:49 a.m. lol. Okay, but see ya some other day. Honestly, I appreciate you joining the stream, Smart. I'll catch you next stream. Also, make sure that you get your 8 hours of sleep. That is the priority here. That's it. Stop and look at this. Honestly, with me, you're not dense, but you also didn't do what the exercise asked, and I want you to see it exactly where it went sideways so it doesn't happen again. What actually happened? You skipped the predict before running step entirely and ran straight to the code. That's the real issue here, not the clustering, Not that clustering is confusing. You said it was hard to visualize without ever seeing it once. I hear that. But that's why the prediction step exists. Predicting wrong and then comparing against real output is how the concept actually sticks. Running first skips the part where your brain does the work. And now, separately, and this is the bigger catch. Your dataset isn't what I asked for either. Look at you build. X equals to a list of two lists. This is 2 rows, 3 columns. Meaning 2 data points, each with 3 features. That is true though. Okay, like points, XYZ, and Z value. That's why cluster underscore centers gave you 190, 80, and 70, 60, 50 with only 2 points and K2. Each point just became its own cluster. No averaging happens at all. And inertia is exactly 0.0 because every point sits exactly on its own centroid. There's nothing to average because there is nothing to group. You have exactly as many points as clusters. What I actually asked for was 6 separate ID points. Oh my gosh. Are you kidding me? By ID, I thought Claude meant one dimensional. This looked like 1D. Oh my gosh. Okay. It would have made so much more sense if Claude just said it to be. Oh my gosh. Okay, you know what? I don't even think that was on Claude. I should have confirmed that whether or not that was ID, because this is what I usually do. This is what I usually freaking do. Okay, so this is going to be 100, and then we're going to go with the comma, and then this is going to be 90. I'm going to go with the comma. You guys see where my touch typing starts to get messed up, and I need to click individual buttons that my fingers are not used to clicking. Like, I can look up, and I can totally write 60 now. But I don't type nearly as many numbers. And once I mess up once, that just ruins my whole rhythm. Wait, that's 1, 2, 3, 4, 5, 6. 50 is going to be the last one. Perfect. I'm going to hit Control S to save the code, and then let's just go ahead and run this. Totally different outputs. 85, 55 one output. 0, 0, 0, 0, 1, 1. Alright, and then we got our inertia of 550. Ah, I see. When you said, let's go with something like 1D, I read it as ID, which I thought meant, wait, when you said ID, oh god, are you kidding me? When you said ID, I read it as 1D, which I thought meant one dimensional. So a list of items, not a list of lists, because that would be considered two-dimensional. However, that was on me to not confirm and ask you. Okay, and then I'm just gonna go ahead and let's see fix one of my typos and let's send it. I'm actually gonna send my code as well real quick. Let's go with Control A, Control C. There we go, and then I'm gonna paste this and send it. Stop right there, you did it again. You ran the code without giving me the predictions for a second time in a row. I told you explicitly predictions in writing first, so running until I see that term is no longer a suggestion. That's the whole point of the exercise, and skipping it twice means I need you to actually hear this, not past it. I'm not going to touch your output yet. Go back and using this exact same code you wrote, give me your 3 predictions right now in writing based on 100. What do you expect cluster underscore centers to do? That is supposed to give me an average, right? So I'm gonna go with an average of 100. Let's go with something like 100 plus 90 plus 80 divided by 3, which is going to be 90. So I'm gonna add a list of 90. And then we're gonna go with 70, 60, 50. So I'm gonna go with something like 70 plus 60 plus 50 divided by 3. That is going to be 60. Okay, this is what I predict my cluster underscore centers underscore will look like. And then let's go with labels. Labels that I predict is going to be 000. Okay, wait, let's go with something like 000 111. This is what I predict my labels underscore will look like, even though these are absolutely wrong. Okay, and then I'm gonna go with something like inertia. Inertia is something that I do not know how to calculate yet. Okay, and then let's just go ahead and send it real quick. I'm gonna go ahead and exit that. Good, that's better. You actually reason now instead of running blind. Let's check your work piece by piece, and I'll teach you the piece you're missing. Cluster underscore centers, very close. Let's verify with real numbers your data. 190, 80 should group together. Tight close numbers, and 70, 60, 50 should group together. That's the real gap between 80 and 70 compared to the gaps within each group. Actually, wait, let's check that. 190 is 10, 90, 80 is 10, 80, 70 is 10, 70, 60 is 10, 60, 50 is 10. Every gap is 10. Do you see it? This is the same evenly spaced problem as your first data set. Just smaller numbers this time. There is no clump structure here at all. But k-means doesn't care whether real structure exists. It'll still force two groups no matter what, since you told it k equals to 2. It'll just split down the middle. So 190, 80 as one group, 70, 60, 50 as one group. Nice work, that's correct math reasoning, not a guess. Oh wow, so my math was correct. What the genuine hell? I got 90 and 60. Why did I see 85 and 55 there though then? Which is kind of close to 90 and 60, but we'll see. Labels underscore also correct. 000 3 points in group 0, 3 in group 1, matching your 000 But here I had 000 Inertia, you don't know how to calculate, so let's build it from scratch right now instead of guessing. We call the definition sum of squared distances from each point to its own centroid. Group 0 points, 190, 80. Centroid is 90. Distance from 100 to 90 is 10. 10 squared is 100. Distance from 90 to 90 is 0. Squared, 0. Distance from 80 to 90 is negative 10. Just distance, so 10 squared is 100. Distance from 90 to 80 is 10. 10 squared is 100. Distance from 90 to... Huh? Oh, centroid is 90. There we go. Centroid is 90. I get it. Group 1 points to 70, 60, 50. Centroid here is 60. 70 to 60. Distance is 10. Squared is 100. 60 to 60, 0. So squared is going to be 0. 60 to 60. Distance is negative 10, which basically means 10 squared is going to be 100. Now, add every one of those squared distances together. What number do you get, and does that match what real k-means would report as inertia? I get 400. I get 400. That's off. Let's rewind. Recount with me. 100 plus 0 plus 100 plus 100 plus... Add them all at one time. What do you get? I get 400. Do I not know math? Wait, do I not know math? What is 100 plus 0 plus 100 plus 100 plus 0 plus 100? Are you genuinely kidding me here? Dude, okay, 100 plus 0 equals to 100. And then 100 plus 100 equals to 200. Then 200 plus 0 equals to 200. Then wait a minute. Wait, 100 plus 0 plus 100 plus 0 plus 100. 100 plus 0 plus 100 plus 100 plus 100 0 100 100 0 100 0 100 equals to 400. There are 4 hundreds. There are 4 hundreds and 2 zeros. So it is 400. What the hell? Hold on, walk it with me. Don't jump to the total conclusion. Bro, am I bad at math? 100 plus 100, 200. 300. 300. Guys, what's wrong with Claude? Then 400, not the earlier 6 numbers at once. Jumbled also happened to land on 400. Same guess, but now you got there by actually adding step by step. What in the genuine world was I doing before? Instead of guessing the total number from a pattern, didn't I just give the entire freaking calculation up here? I can't believe I had a simple math conversation with Claude for like hundreds. All right. I think that was my math lesson. Okay, so you calculated inertia is 40. Now you ran this code earlier, and the real output is sitting right there in your terminal history. What did model.inertia print out? I got 550. Is Claude teaching me something wrong, or none of the outputs match? Did I learn something wrong? Interesting. Okay, I guess let's just go ahead and send it. Top good instinct to flag the mismatch instead of ignoring it, but you haven't learned anything wrong. Look closer at this output before assuming the concept is broken. Look at cluster underscore centers underscore first. 85 point, 55 point. You predicted 90 and 60. The real output says 85 and 55. That's different from what you calculated by hand before touching inertia at all. Why would the real centroids be 85 and 55 instead of 90 and 60? Go back to your actual data. 190, 80, 70, 60, 50. You assume the split was 190, 80 and 70, 60, 50. The top 3 and the bottom 3. But actually, the split that K-means landed on. Look at the real tables. Oh. Count the zeros and ones. How many points are in groups and how many are in group 1? Wait, it's split 4 to 3. No, 4 to 2, 4 to 2, 4 to 2, 4 to 2. Exactly 4 to 2 and not 3 to 3. That's the whole difference. That's the whole discrepancy right there. Your hand math was correct arithmetic, but it was solving the wrong split. Now, figure out which 4 points and which 2 points using the real label underscore order matched against your original x equals to 190, 80, 70, 60, 50 label underscore 00011. Line them up. Which actual numbers got zeros and which got ones? 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. 190, 80, 70. So 100, 90, 80, and 70 got 0, while 60 and 50 got 1. I'm gonna drink some water, which I think I forgot to drink when I got my bottle, unless I did. Exactly right, so group 0 is 190, 80, 70. 4 points, and group 1 is 60, 50, 2 points. Now redo the centroid for real this time. So to find the centroid, 100 plus 90 plus 80 plus 70 divided by 4. Let's grab the calculator. So 100 plus 90 plus 80 plus 70 equals to 340 divided by 4 is 85. Okay, and then 60 plus 50 divided by 4 is 27.5. Oh wait, divided by 2, my bad. 110 divided by 2.
So are you in?
Oh god, I clicked my Wuthering Waves. That's it. So are you in? That's alright. Calculator. I should get my calculator here. That is 55. Oh, they do match. Okay, and I was so close to my timer too. No way, I clicked my Wuthering Waves. That's fine, I'll just reread that stuff. There it is, mystery solved. And notice what actually happened here. Your math wasn't wrong. Your assumption about the grouping was wrong. Okay. Now finish your job. Recalculate the groups. Centroid. Okay. Yada yada. Okay, that's it. That's time. Hands off anything that is distracting. Back to Wuthering Waves. So apparently, I did sort of click my Wuthering Waves. Let me say that again. So apparently I did click my Wuthering Waves while I was working with my Pomodoro or whatever my timer is. And I had one conversation, but this is basically it. So are you in? You guys just didn't hear that. That's it. You don't sound like you want to save the world.
Nuh-uh, I don't. The world? Couldn't care less. If it's all going boom tomorrow, why not have fun while we can?
Interesting.
To stop at nothing for more power. Take down any prey without mercy, and indulge in all our desires for the ultimate pleasure.
Alright. How are you any different from the Fraxidas then?
Well, I mean, I'd love to live that way. But alas, duty calls. The Black Shores, our garden, is home to many green fruits, and we'll make you the most special seed among them all. My duty is to nurture and safeguard seeds like you, allowing them to blossom into luscious fruits.
Why did he close his eyes? Is he getting like brainwashed or something?
Then, once the fruit ripens, I'll get to pick it and indulge the sweetness of my labor all by myself.
A fruit? That's none of my business. I'm gonna go with a fruit.
You're just like what Civilization Simulation Sandtable Tethys has told us. I can feel such explosive potential within you. One day, you'll surely bear the most beautiful fruit imaginable. No need to be so on edge. I won't do anything strange to you. I think. Actually, I've been diligently protecting you, you know. I got rid of all types of pests that tried to get in your way.
Like?
Ew. Don't mention me and the Fraxidas in the same sentence. I couldn't care less about their petty games. But if they even think of laying their dirty fingers on you, you're mine. And I don't like sharing.
She gives me Yandere sort of vibe. Is she like a Yandere wife or something like that?
Just a couple tricks and I had those fools flapping around like headless chickens. What a boring crowd.
Tricks? Those fools?
Whoa, don't tell me you haven't noticed. Enjoyed your nightly rendezvous with that long maiden? You have me to thank for keeping those Fraxidus people away.
By the long maiden, does he mean Susu? Yang Yang's sister or someone else?
Well, I've answered plenty of questions already. Now it's your turn.
Oh, here goes. Wait, okay, I thought it was gonna be a cake. Okay, what do you want to ask? Is this how you treat the talents you're trying to recruit? I'll just go with directly what you want to ask.
Nothing in particular. The way you look at me, though, it's almost as if... No, forget about it.
Okay, I want to make sure that you guys can actually hear this. Man, is my like headphones charged? Hold on, let me check it out. Let me test it out. I think that I may have enough charge for it to actually work. Okay, let's change this to my headphones and then I'm gonna play it real quick. Oh god, are you kidding me? That didn't even... Okay, defaults. Okay, but I'll be watching you. You're a very special seed that I am very sure. I want to see if it works somehow. I don't know.
I can feel something
Perfect.
oddly familiar about you.
Whoa. What was that?
My name is Camellia.
Melia.
Try not to let me catch you so easily next time.
And she's gone. Huh. That was fast.
Interesting. Okay, that's time. Hands up anything that is distracting. Moving on. Back to work. Back to work. Okay, there it is. Mystery solved. And notice... Did I read this? Okay, now recalculate. So since it's blocked with 2 centroids, okay, so labels should be... Okay, what was the... So labels, so model dot labels underscore is going to be equal to 0, 0, 0, 0, 1, 1. And then we're going to go with something like models or model dot inertia is going to be equal to, let's say there's a gap of 10. So, okay, wait, hold on. I need my calculator for this. So we go with something like 100 plus 90 plus 80 plus 70 divided by 4. We get the average, which is going to be 85. And then we're going to get the average of our... Oh, we already had our average. The next average is 55. In order to get our inertia, same square distance method as before, show your work terms by term. Okay, 85, right? So 100 square, 190 is going to be, for inertia, 100 to 90 equals to 10, which is going to be equal to 100. Okay, I may get this in a new line. And then we're going to go with something like... the inertia is 85, right? So 100 to 85. 100 to 85 is going to be 85, 15. So this is going to be 150. That will be 15. There we go. And once we're done with that, for the next one, what's your roadmap for machine learning? Actually, I do not yet have a roadmap for machine learning. Spoilers alert, that may be the next series that I will be working on. For the time being, I do have a roadmap for AI engineering that does consist of an entirely dedicated phase for my math and machine learning foundations, where I am currently working with, let's say, classic machine learning Scikit-Learn under the subcategory of, let's say, clustering. For the time being, it is k-means, but later on in this roadmap, I will be working with, let's say, I will be working more with machine learning, which should be somewhere up here, right? Okay, am I blind? Wait, okay, I could have sworn I saw another machine learning here. Wait a minute, hold on a damn minute. There we go. We're gonna work with more machine learnings that has subcategories of let's say GitHub actions, testing AI outputs, blah blah blah, and all those stuff. So if you do want access to my AI engineering's roadmap, which is not machine learning yet, but it does have deep learning and machine learning inside of it as prerequisites to be an AI engineer, you can join my Discord server and either go to the coding helps us chat, Python chat, or the general chat. Hold up. There we go. Either go to the coding helps us chat, Python chat, or the general chat. Mention my name there at VivUniverse, asking me for the roadmap. I will be personally DMing it to you as soon as this stream is over, and you guys can get access to my Discord server through the link in the description, through my bio, or by typing exclamation Discord on chat. All lowercase, no space, and link should pop up within 3 to 4 seconds. That said, so I found the first inertia. Now it's time for the second number, which is going to be 90 to 85. So 90 to 85, which is equal to, let's say, 5. 5 squared is going to be 25. Okay, and then we're going to go with something like 80 to 85 is 90 to 85. Okay, 80 to 85 is going to be 5 again. Like, literally, it's going to be 5, right? So let's go with something like 80 to 85 is going to be equal to negative 5. That is going to be equal to 25 again when squared. And then we're going to go with something like 70 to, oh God, let me think. 70 to 85 is going to be equal to negative 15. That is going to be equal to 150 again, because 15 times 15 is not 150. I lied. 15 times 15, 225. Okay, now we do the math. So we go with something like 225 plus 25 plus 25 plus 225, whoops, is 500, but it's not 550 yet. Why so? Inertia. Let me think closely about inertia. So we had zeros before. We had a whole math sequence here, which I'm kind of glad that we do now. Oh, wait. We go with both of them. 90 to 90 is 0. I don't have a damned thing here. That is 5. Okay, so that's 15, which is 225. That is 5, which is 25. 82. 85 is negative 5. 80 to 85 is negative 5. I don't know, though. This number is going to be getting tremendously huge if I were to go with something like 60 to 85. No, now the second one's gap. Okay, the is 50. So 60 to 50 is going to be equal to 10, which is going to be equal to 100. That gets me up to freaking 600. And then let's go with something like 50 to 50 is going to be equal to 0, which is going to be equal to 0. And then 40, is there a 40 here? I think there is a 40. So 40. No. 60 and 50 is 55. Oh my gosh. My brain is not braining. Hold on a damn minute. Okay, it's starting to. 60 to 55 is gonna be 5, which is gonna be equal to 25. And lastly, we're gonna go with something like 50 to 55 is gonna be equal to 5. That is gonna be equal to... Wait, -5 is gonna be equal to 25. And now we add every damn thing up. 225 plus 25 plus 25 plus 225 plus 25 plus 25. That is going to be equal to 550. There we go. That's exactly right, and clean working on. No shortcuts this time. Every distance computed and squared individually before summing 550 matches in real output exactly. Let's go, let's go. You just fully close the loop on inertia. You know what it means. You know it's squared. You know it's square distance, not raw distance. Notice negative distances like -5 and -15 still became positive, and positive 25 and 225 one squared, which is why it's called sum of square distances, not just sum of distances. And you hand verified it against real k-means output twice. So once wrong from a bad assumption, once right after correcting it. Here's your bigger lesson sitting underneath all of this, and I want you to actually internalize it. You cannot assume which points land in which cluster just by eyeballing the data. Always check labels underscore directly before doing any follow-up math. That's not one-time fix. Now that's a permanent habit for every clustering exercise going forward. Quick check before you move on. In your own words, why did assuming 3x3 split fail here? Tied back to what k-means actually optimizes for. We cannot predict where it may split because k-means finds the most effective split. Okay, and then I'm gonna go ahead and send it. You're circling the right idea, but it's a little vague. Most effective doesn't say what it's optimizing. Let's tie it back to something concrete we already know: inertia. K-means isn't picking a split because it looks clean or feels balanced. Like your 3x3 guess, it's running that loop you learned earlier. Assign each point to its nearest centroid, move centroid to the average, repeat, and it keeps doing that until the centroids stop moving. Whatever splits that process settles into is whatever split happens to minimize the total distance from points to their own centroid. Okay, so minimize inertia for that particular run with your evenly spaced data gaps of 10 everywhere. There's no obvious correct clumping, so the exact split 4233 or something else can end up depending on where the random starting centroids first landed, not on some clean rule you could predict by eye. Try it once more in your own words. Wait, what? I think I need to wear my glasses. Hold on a damn minute. Got too bright for me to understand. K-means isn't picking split because it looks clean or feels balanced. Like your 3-3 guess is running that loop you learned earlier. Assign each point to its nearest centroid, move centroid to its nearest centroid, move centroid to average, repeat, and it keeps doing that until the centroids stop moving. That's whatever split that process settles into is whatever split happens to minimize the total distance from points to their own centroid, minimize inertia. For that particular run, when you're evenly spaced, gaps of 10 everywhere, there is no obvious correct clumping, so the exact split 4 to 2, 3 to 3, or something else can end up depending on whether the random starting centroids first land or on some clean rule you could predict by eye. Why can't you assume the split? Okay. It's running that loop you learned earlier. Assign each point to its nearest centroid. Because it assigns each point to its nearest centroid. Hey, I did not understand why. Okay, let's send it. Okay, good, you're not faking it. You flagged the confusion instead of forcing an answer. Let's rebuild this slowly with real numbers so you can see the eyeballing fails. Yo, how important is the math behind the algorithm? I think when it comes to machine learning, math is one of the most important things. You need to be really fluent with calculus, advanced level calculus, linear algebra, statistic, let's say I forgot what else because I haven't really worked much with machine learning, although it's not nearly as important for AI engineering. That said, you still do need to know a bunch of those things at a basic level if you still want to be an AI engineer. And I feel like machine learning engineers and AI engineers, the thing that they do at a basic level kind of collide. It just gets different when they're like at, should I say, an intermediate or advanced level. But what do you mean by is the math important behind the algorithms? Do you mean like when Visual Studio Code is trying to run this program and like train a model? Because then yeah, the math is really important because that's what finds the averages of all my datas here, splits my datas in center, and let's say displays to me my labels, displays to me my centroids, and figures out what my inertia is after getting the average of the distance between our first group and our second group. After it gets our averages, they just square the averages and sum them all up, if that makes any sense. Because that is really important. I haven't really put this into a real mini project to like be really explicit as to what kind of projects would the inertia here be useful for, but I will be working on that really soon. I mean, like, suppose we're learning lasso regression. So we should know the mathematical intuition from the scratch because we can just call lasso object from Scikit-Learn and use directly. Okay, the reason I am working with the math here is just so I understand what happens internally. You don't really need to know the math to like run those modules and all that stuff, because 90% of the stuff happens internally. But if you just run those modules, or let's say those specific classes or instances from those classes without understanding what's happening internally, I feel it sort of does feel like a waste of time unless you're not like wipe coding where you're completely relied on AI to like fix the errors, and whenever you get a new error, you tell it that I got this error, fix this certain thing. But if you wanna know what's happening internally, I would highly recommend learning the math part as well. You don't need to be a math wizard, just understand the basics of what's going on inside. And then you could always use the new methods. Same thing, that's the same thing that I worked with when I was, let's say, working with basic Python methods like the sum method, or like, I forgot what all methods. I first worked on learning the math manually, and then when I knew or I understood the math, that is when I really worked with the actual methods that kind of makes the work easier to do. For example, the is alpha method or is alpha num method. Okay, that was the hardest thing to phrase. That said, okay, your data again, 190, 80, 70, 60, 50, evenly spaced by 10. Alright, UW. Okay, remember the loop. 1, drop 2 random centroids somewhere. 2, every point joins whichever centroid is closer to it. 3, each centroid to the average of its groups. Repeat until nothing moves. Here's the part you're missing. Step 1 drops centroids randomly, not at the middle. Not a clean boundary, randomly, could be anywhere. Let's trace one possible run by hand. Say the random start drop centroid at 95. And the centroid B is at 55. Oh, so it's random. Okay, step 2, every point joins its nearest centroid. Let's check 80. 80 is closer to 80. To A, 95 or B, 55. It's closer to A, 95. Distance, 15, 25. 80 is closer to A, so 80 joins A's group. Oh. Even though 80 is pretty close to 70, which might end up in B's group, the point doesn't care about its neighbors and only cares about 2 centroids it's near. Now, you try the same check. Is 70 closer to 95, or is 70 closer to 95 or 55. Oh god, you really expect me to do the math again? Okay, so we're gonna go ahead and check the distance. So what is 70 minus 95? It is 25, negative 25. And what is 70 minus 55? 15. It is closer to B. It is closer to B. Then let's send it. Exactly, right. 70 joins B, not A. Now sit with that. Now sit with that means 80 joined A, but 70, its immediate neighbor, only 10 away, joined B instead. The top half slash bottom half split you assume does not hold because each point is making an individual decision based on raw distance to whatever the two centroids currently are, not based on some clean midpoint of the data set. And here's the real kicker. Those centroids at 90 and 55 were just random starting guess. Once every point picks its nearest one, step 3 moves the centroids to the average of whoever joined them, and the whole thing repeats. So the exact number you end up with, and therefore exactly where the split line falls, is dependent on where that random start happens to land. Different random start, possibly different split. Now, full circle, try the original question one more time using what you just traced by hands. Why can't you assume the split by eyeball? Top half, bottom half. Okay, because k-means finds the centroids randomly, and based on what number it finds, it stays with the group that is closer to it. Okay, even though I do need more practice, that's it. You've got the real mechanism now, not just the phrase random starting centroids, each point independently, join whichever one is closer to it, and eventually split falls. Alright. That's exactly why your label stuff. Okay. You've now fully closed k-means code. Okay, blah blah blah. Two things before clustering is fully closed. The elbow method needs to be applied to a chart with real code. You've got the concept, but you haven't plotted inertia across multiple x values, and then dbscan hasn't been touched at all given where we are. Want to keep pushing into plotting inertia across several x values right now, or take a breather here since this was a dense stretch? Okay, I will definitely take a breather because I still got some college work to get done, but before I really go and take any breathers, I'm gonna kind of close this and say something like, let's say I had a quick question. Okay, so my question was, eventually, later on in the roadmap, will I be working with these topics again, question mark? Again, to get more practice, question mark? Because even though I understand this now, it is not like I will end up forgetting it. Let's go with something like I will end up forgetting it. However, I will be needing more practice and a refresher in order to, let's say, get it back on memory. Okay, was this the whole question? Later on in the roadmap, I'll be working on this topic again, more practice, because yada yada, blah blah blah. Okay, I think I wanted to say something else, but I'll send this for now. Real question, it deserves a straight answer, not a vague reassurance. Short answer, yes, but not as dedicated. But not as dedicated. Let's redo k-means module. It comes back into later work, not as a scheduled Refresher. Here's where it actually resurfaces on your roadmap project 2 right after model evaluation. Still in phase 2, you're building a predictive model from scratch and writing it up like a client deliverable. Depending on what you pick, clustering could directly show up if the problem is unsupervised shape. And even if it's not, the no label, find structure yourself. Mental muscle carries over how you think about the data. Phase 4 RAG architecture, vector databases and embedding lean heavily on distance/closeness reasoning, which is the exact core intuition you built with the number and exercise. Different tools, same underlining. How close are the two things to each other thinking? Okay, that would make sense because I don't really need an entire explanation starting from scratch. I would just need a refresher because again, all the topics that you first work on in this roadmap basically act as an exposure phase where I'm being exposed to chemies, I'm being exposed to cluttering, etc., etc. Later on, we get more practice in order to reinforce that stuff. Phase 6, agentic system, which I am the most excited for. By God, when am I going to reach phase 6? Memory systems. Epsodisk, is that how I pronounce it? Semantic memories sometimes use clustering hyphen adjustment techniques to group similar memories or experiences. Wait, it does not get a dedicated clustering round 2 block sitting somewhere later just for repetition. The roadmap is built around forward progress, not space repetition review. Given your own pacing philosophy, full exposure now, not heavy mastery reps. Now that's actually consistent with how you wanted every topic handled so far. Get it? Thought for real ones, verified against real output, and trust the later usage. Not a scheduled redo is what turns exposure into retention if you want a personal safety net. Beyond that, the MD summary files. There we go, the MD files is what really matters here. That's it, that's time. Hands off anything that is not distracting. Moving on back to Wuthering Waves. Oh wow. Gonna get this here real quick.
What took you so long to answer? Did something happen?
No, wait, is this like a hologram? Oh, it is like a call. What took you too long to answer? Another stalker showed up. I encountered a strange woman.
Is that a friend or foe? Are you hurt?
She's from the Black Shores. I'm safe, thank you for asking.
The Black Shores. Did she tell you anything?
A shame I let her get away.
Phew. At least you're safe.
Alright.
Shuxian noticed a guy acting suspicious. I think she's keeping an eye on him.
I'll be there soon.
Sure. We are in the shopping district. See you then.
Wait, we're in the shopping district? That sounds fun. Wait, can I? What if I go with Rebecca? Okay, I was gonna kill them for like meat, but they're cats. Oh, hell no. I'm just gonna mind my... Can I get a screenshot with them? Are they gonna move? Oh, they're so cute, kittens. Oh, God. Well, I think they're actual cats. In case you guys did not know, I love cats so much. Woohoo! A tragedy that I don't have any. Okay, what was that? Gloom Slout. F to collect. A material used for synthesizing. Okay, will I make it? Will I make it? This place is filled with items that I could fill my inventory with. There we go. Oh, I'm in Jinzhou. I wonder if I take water damage if I fell. Is that like a lion? Okay, let's keep going in front. I think air travel is so fast. Not really as fast as me being able to run. You cannot currently use this function, damn it. Whoop. There. Oh god, that was a close call. I could have died with the fall damage. This place is filled with cats, what the hell? Oh, look at the cat. A good thing is they don't really panic looking at me like how actual cats do. Okay, can I is there a way to like adopt them?
Here we go.
Okay, I gotta be more precautious or more time preservative. Is this a shopping district? Slowly but surely on my way.
Rover, there you are.
Did they take the bait? What kind of bait? How's it
We
going?
walked the streets, wearing the Blake bloom like you said.
Oh, the bait
Talked
for
to
the
various
bloom.
people, but I didn't hear anything useful.
How about Jisia?
Shizia did say she found someone suspicious. Look, it's him.
Him whom? Oh.
Rover, perfect timing. This guy's been sniffing around here for a while now. He keeps trying to talk to the elderly and minors. I've been keeping an eye on him. And I saw a little girl with him. She kept turning her head and looking around, but now she's nowhere to be found. This is super fishy.
Alright, what in the genuine world? Is this like a situation to call the cops or something?
Hey, I'm Patrol Letitia. Sir,
Oh, the cop is right
business
here.
license, please.
But business license? Uh-oh. I'm Alto, just a humble information broker. I've been traveling around, helping people out in my own small way.
I see. So no license. I bet you don't have a fixed business location either, huh?
Business location? Why would I need that?
Definitely suspicious.
Now show me your organizational accreditation, please.
Well, I'm an honest broker of information, always open to negotiations at the right price. I'm the all-time Intel champ, with more bestseller certificates than I can count.
Alright.
No license? No clear business plan? You're running an illegal business. Then who's your supervisor? You should at least have their ID number.
My supervisor.
He's not got squad.
Oh, right. She's like
What
a
the hell?
super big deal. She's an ancient being, born with this planet we're living on. She's the will of a star, the reverberation of everything in this world.
Nice storyteller. Are you for real? I'm not buying that.
So do you even have a supervisor or not?
What? Come on. I already told you about her. Why won't you believe me?
Well, maybe because it wasn't convincing enough.
Yeah, I believe you. I know what's going on. Now, sir, you're coming with me to the patroller station.
Oh, come
Did he
on.
just dip?
Please. I didn't do anything illegal. I was just looking for someone. A little girl. About this tall. She's the kind to stand out in any crowd.
You really think I'm gonna buy that?
Ah, you saw her earlier. It's that girl.
A short girl, a pink-haired girl, she seems to bounce while she walks. What's that supposed to mean?
Yeah, exactly. Wait, how do you know?
Is it that, the tree girl who, like, jumps around, and she made them she's a resonator, I forgot her name. Who they spoke to. Or is it someone else? There we go. Oh, wait, not her. I was talking about her. I was talking about the other one. Please, no, I'm gonna quit the game.
It's dangerous to run like that. Here you are! Hooray!
Interesting.
Encore! I've looked everywhere for you.
Encore.
Back off! Leave that girl alone.
Miss Patroller. She's the girl I've been looking for.
Hello, little one. Is your name Encore? Do you know this person?
Yes. Encore knows him. Uncle Alto sells stuff without a license. He listens in on people for commercial secrets, and he loves pulling pranks on us kids. But he's not a bad guy, really.
Kids are the most innocent person. Just said he works without a license. What the hell?
Encore! Remember our little chat?
Remember our little chat?
What did I say about calling me uncle in public again? I am
Oh.
not that old.
Is that what his concern was in that whole sentence? What the hell? That doesn't add up with what you just said. Of course, probably because he was lying. You sound really suspicious to me. Is that what you're gonna focus on? What I'm saying?
Miss Verena? Where did you meet this girl?
I was
I
talking
ran
about her,
into
the
her near a
resonator.
cliff on my way home. She was eating a poisonous mushroom.
Uh-oh.
I managed to make her the antidote in time. Imagine what would have happened if I wasn't there. Don't worry. Encore's had plenty of that mushroom already.
But why did you go to such a dangerous place alone, little Encore?
Don't say anything.
We got your back, little one. No worries. Just tell us what you know. Because Encore must keep an eye on him.
Look at the creepy smile. I'm dying.
Kids can have such wild imaginations sometimes.
Only one with an imagination right now is him here. He thinks we're buying it.
Hey, Alto! Didn't you just send Encore there? Wait, why are they all giving you the side-eye?
The bombastic side-eye.
Encore! Some things are better left unspoken, you know. Since the situation has come to this, I've got no choice but to tell you.
Finally.
Indeed! We're here for business, and it's a crucial one. You want to know what it is?
Is that a smokescreen?
Let's go, Encore!
Hey! Alto! Wait for me!
Are they just gonna wait for that? Are
See
you just
ya!
gonna let them
We
leave?
still have a world to save!
Wait, there are these strong people.
Wait!
This is why you hold on to your captive.
We can't let him get away!
Look for
I'll
Alto.
go search in the residential area.
Try a new session for practice. The Mist of Alto. It's posed in a weird way, as if he can eagle spreading his wings, as if he's an eagle spreading his wings. Did he leave her to mock you? You're not quite sure. In front of the mist figure, there is a floating line of handwriting, also made out of fog. We value integrity and quality above all else. New customers enjoy 20% off. What the hell? Hit me in.
What is this? Is he mocking us? I'll go down that way towards the patrol station.
Wait,
I know
where am
the
I
streets
expected
here
to
like
go?
the back of my hand.
What level would you like to challenge this time? Newbie easy town level. Wait, what? Challenge again if you ever find time. Okay, where am I expected to go? Rewind raindrop. Oh, it's right there. Okay, I was trying to find that.
Here we go.
We go. There. Here? What do I click? I am so genuinely confused. What to do here? Oh wow, and I'm almost sort of dead. Okay, so apparently I gotta go up there. I'm gonna remember that place. Keeps disappearing. Here? There we go.
They say you have claws.
Does it look like
I
I do?
heard you can tear those
Oh, the
monsters
guy.
into
Want to take a look?
I'm so scared when kids come in games like these.
Okay then. Here you go.
Doing the claws, right? Wow, there we go, the claws. Oh wait, eek. That was scary.
Candies!
Candies.
Try some. I hope these candies can make up for not showing you my impressive claws.
Alright, he's chill. I like him.
See? He's not scary at all.
He's a nice guy.
Thank you, Ling Yang.
You're welcome. Do come by to see our lion dance show tomorrow.
Oh wow, definitely.
I will. See you soon.
You smell unfamiliar, yet so powerful and so pure.
Do I smell funny? Are you talking to me? Or she's talking to me?
You must be that famous rover. Hiya, I've heard a lot about you, and now I finally get to meet you in person.
Been a pleasure.
You can call me Ling Yang. Glad to make your acquaintance. Fare thee well, blessings swell.
Fare thee well, blessings spell. What the hell? I'm Rover. Reach out to your hands. Rover, don't reach out your hand. Oh hell no, we're reaching out our hand.
You really are different from everyone else. So we've shaken hands. Now we're good friends.
Okay, that was a mistake. What are you doing here?
Our troupe is doing a big lion dancing show tomorrow evening, and I'm now doing some advertising.
I'm all down for the lion dance show. Hey, you trope, a lion dance show. And okay, that is time as well in 3, 2, 1, there. I will be ignoring the timer now because I'm pretty much done for today's work. Tomorrow we will be starting our second topic of clustering, which is database scans, and then we're going to move on to dimensionality reduction, and finally model evaluation. But I'm going to complete this story real quick, and then I'm going to call it a day for today. And also, I forgot to charge my ring light after my headphones. There we go. Let's charge it. Okay, your trope. Our trope is doing a big dance. Okay, I'm gonna go with trope. I want to know what trope.
Yeah, the lion dance troupe. We do cool lion dancing shows for parades. Oh, and lion dancing is a traditional thing in Jinzhou. We've got lots of activities in Jinzhou. I can't wait to show you. Oh, oops. Sorry. I guess I'm a bit hungry after rehearsing for a whole day.
I just realized he's a resonator too.
Speaking of that, I should treat you to dinner. Let's talk over food. That'll be fun.
That's a thing in Jinzhou too. You seem a bit too kind. What do you want from me? I'm more of a direct person, to be honest.
Nothing. Please believe me. I'm just trying to treat you to a meal, since you're our super important guest and all.
That's what they all say, though. It's hard to trust people.
You'll see how we roll with our guests soon enough.
When it comes to anime, guys, I think that they say it genuinely. Real world people, they're completely different. Do not trust anyone if they say something like this, unless you guys are acquainted in some way.
But right now, I still have some other things to finish. I've been getting a ton of requests for private lion dances lately, and some happen to overlap with our big show tomorrow. And you know how important lion dancing is to the folks here in Jinzhou. Can't just turn them down. So, I had an idea. Why not combine all these personal requests into the grand performance? That way, everyone's happy.
Alright.
We can even customize the performances to cater to each client's needs.
I'm all down for a nice little show.
But first, gotta figure out exactly what our clients want.
Firstly, didn't you want to eat something?
Rover, wanna come with me? We can go visit my clients on our way to grab food. I'll show you around and introduce you to our local customs firsthand. It'll be way cooler than just hearing about it from others. What do you say?
Nice in, since it's your treat. I'll just go with nice in. But I'm gonna follow them tomorrow if I had an option.
Great! Let's go!
Let's go. There we go. There we go. Comparison story Ling Yang. Wild. What that was?
Okay.
Okay.
Let me think. My first client's nearby. You might have seen them before.
Is that it?
Just cross the bridge, keep going, and we're there.
Cross the bridge, keep going, and we're there. Okay, V to navigate. Okay, for the time being, I'm just gonna go ahead and exit, but before that, I want to open events just to see if I get any freebies. Because I am always down for freebies. I can get a bunch of airstrikes. I just don't know how to participate in these things. Okay, and then what is that? There's like a huge exclamation mark there. There are a bunch of goals, but I'm not gonna go anywhere. Wow, he looks kind of cool. Rumbling Hollows. There we go. I knew it. Oh my gosh, 40 airstrikes? Say no more. That was so worth it. Okay, and then now we're gonna check our mail. I'm gonna claim all. There's nothing to claim. I can delete stuff. And then we got our expedition bike. We got our resonators. We got our backpack. I want to see what's in my backpack. We got a fox mask. I was just gonna call it a kitsune mask. That's fine. And we have our tutorials, which I will not be playing. I want to check the convene, which I did already check. Suzu is the character up here who I would have summoned for, but I'm still saving up for someone even better. We got a reverb character for the next 13 days, which is Yin Lin. I don't have enough asteroids to like summon for them right now, so I'm just gonna go ahead and save. Yeah, I'm just scouting here just to see if everything's going good. So Suzu is the brand new character, and is she a new character as well? Aim it. I'm not gonna go with the trial, but that's fine. Okay, I think that's pretty good. And then resonators lastly.
Why hesitate if you know what you want?
New voices, that's pretty much it. I'm gonna just try
Why
to see
hesitate
if I
if you
can
know what you
ascend them.
want?
Oh, we cannot ascend them yet. Alright, okay. If I were to ever ascend someone, it's definitely gonna be Rebecca. Need to hit some.
Yo!
No mind. Okay, I think that's pretty much it in that case. I'm just gonna go ahead and let's see, exit Wuthering Waves and then move on to my OBS and go to my main camera. Alrighty guys, so let me open this real quick. There we go. And I didn't even realize that my webcam's configurations were not merely as dull. I like to have it be a bit dull. Hold up. There we go. It's just a shame that it doesn't stay this way the whole time. I mean, unless every time I open OBS. There. Alrighty guys, so basically that was pretty much it for the stream. If you guys did enjoy the stream, don't forget to smash the like button, subscribe and notifications turned on. And if you guys do enjoy my stream / video / content in general, make sure to share my channel because like helps my algorithm sharing, makes you smile, and subscribe link is on top. That said, if you guys do want to follow me in any of my socials, you guys can get access to all my socials through the link in the description, through my bio, or by typing exclamation and the name of the social on chat, all lowercase, no space. If the social does exist, a link is going to pop up within 3 to 4 seconds. If the social does not exist, a link will not pop up. That said, I did create 2 brand new channels, one called Viv Arcade and the other called Viv Works on Viv Arcade, where I daily upload videos. Is specifically meant for my gaming channel, and Viv Works out, where I have not uploaded a video for the past month, is specifically dedicated to my workout content. Therefore, if you guys are interested in either one of those genres or categories and that you guys want to check those channels out, you guys can get access to both those channels through my homepage. If you guys scroll all the way down, I have both of those channels featured, so you guys can follow me there. That's it. If you guys do want to follow me in my Engineering for 365 Days series and that you guys want access to the roadmap that I am currently using for the series, you guys can get access to that roadmap through my Discord server. If you guys either go to the Coding Helps chat, Python chat, or the general chat, mention my name there at VivUniverse, asking me for the roadmap. I will be personally DMing it to you guys as soon as the stream is over though. And you guys can get access to my Discord server through the link in the description, through my bio, or by typing exclamation Discord on chat, all lowercase, no space. That said, I'll catch you guys in the next live stream or video. Peace. Okay, I guess let's end the stream.